Hello. Shopping can be fun for some folks, and some folks just want to get over it. A year ago, my wife and I were shopping at a furniture store for a cushion chair. My wife really liked this rose four-leg cushion chair, but not exactly. So she was telling me about how she wanted something that was a little bit more purplish, maybe 3 legs, and the list kept going on. And then I said, hold on. I pick up my smartphone, load up the eBay app, point the camera at the chair, and I do a visual search. And lo and behold, there were a few chairs that just looked similar to that. She looks at those results and she says, you know what, I like that. I like this. I want to look more like this. And then finally, we were able to find a chair that she liked. A picture can speak 1,000 words. These are the kind of experiences at eBay that we would love and are working really hard to create for our buyers and sellers. Experiences that are magical, that are fun, inspiring, and frictionless. We strive hard to enable such experiences globally using the state-of-the-art AI technologies such as computer vision, natural language processing, and powered by our homegrown AI platform. Today, I'm going to be talking about exactly these kinds of use cases and our learnings towards how we enable those experiences. So let's get going. eBay is a global marketplace. 20 years ago, our founder, Pierre Omidyar, listed the first item on eBay. It was a broken laser pointer. Today, we have over 1.4 billion listings in over 190 markets. A watch sells every 5 seconds. A car or a part accessory once every 1 second. We're not just about used items. 80% of our inventory is new items. We have not just auction. eBay is also about fixed price items. It's a humongous velocity. In the big data world, you would call it as the volume, veracity, and variety. So eBay has tons and tons of data. How do we use these to create those magical, inspiring, and frictionless experiences for our buyers and sellers globally? The way we want to look at it as eBay is an adaptive and managed marketplace. It's powered by AI. We think of it as a set of concentric circles. The outermost circle is the set of user experiences. As a seller, you may come and list an item. As a buyer, you may come and do a search. You may want to exchange messages with the seller. You may want to transact on eBay. All of these are powered by our next layer, which we call as the user AI. They are very much ingrained in the user experiences. As we dig deeper, there are a set of core enablers for our AI. These could be our search, our recommendation, our economics and logistics, language, which is a huge part of eBay, or vision, AI. And at the right and center of that is the data and the AI engine that actually powers the experiences enabled by AI. Specifically today, I'll be diving into 2 areas of our core AI pillar, computer vision and natural language processing. eBay gets close to 50 million plus images a day across these 1.4 live billion listings. When we embarked on a vision that we wanted to set for what kind of experiences do we want to enable with computer vision, we landed on a few. We wanted those experiences to be magical. We want our buyers and sellers to trust those experiences, whether if it's a prohibited item or it's an explicit content. We want it to flag from the images. We want to make it very easy for our sellers or our buyers to really pursue their shopping journey. If you're a seller, we want you to be able to click using your camera phone, take a picture, and then autofill the listing. If you're a buyer, like my wife is, you could actually come in and point to a chair and look for similar looking images. So let me share with you some exciting examples of how computer vision is enabling commerce experiences at eBay. So we'll start with visual shopping. Another cool experience was image cleanup that we rolled out last year, and also an example of how we are able to infer attributes based on just image and power a diverse set of experiences. Let's start with visual shopping. So similar to how my wife and I were shopping for a cushion chair, this is again an image. When we start with, we want to be able to locate objects in an image. So this is from our home and garden, a typical image. And as you can see, the first thing that with computer vision we try to do is to locate what are the objects in the image. And once we do that, we would actually try to identify what those objects are, recognize them. Hey, this is a chair. It belongs to a certain category. This is the color. And what is the use, for example? Is it an indoor chair? Is it an outdoor chair? Is it leisure? Is it an antique type? So image can really tell a lot. And then once we do that, from a visual shopping standpoint, we can enable the buyer to find similar looking items. So here's a chair. We can look at it and look at the different attributes. We call them aspects, as color. Maybe there are prominent features of it, like the legs of the chair, maybe the patterns, and we help the users actually find them. So this is exactly how we enable computer vision. We use state-of-the-art deep learning methodologies and algorithms to really train our models over a corpus of diverse data sets. We use stratified sample data sets across multiple categories. We then deploy them into our AI platform in our inferencing layer, where we run deep learning models at scale in very low latency and high throughput to help our users find their product of choice in split second. So it's really a cool use case here with visual search. And as you can see, we start showing, like my wife and I, when we were looking for it, we uploaded the picture of a chair. It showed a few results. And then maybe there was one that she really liked, like deep purple. And we would basically say, hey, we want to look more like this chair. Started really showing more of those kinds of chair. And really, that's really how we enable such experiences to help the users complete their mission. But it's not just about images. As part of the shopping experience, we also enable the users to start from text, but then use information in the text, the category, and the images to help the users identify and complete their shopping journey. So the next use case I would like to share with you is called the image cleanup, which is, again, we're super excited. Our sellers are super excited. Visual shopping was for the buyers. This one is about sellers. Now, as a seller, you want to be able to really list images that are nice and clean looking, because the buyers love them. The cleaner looking images actually convert better, they engage better. So here is again an example of what that experience is. This is again a sunglass. As you can see, when a seller takes a picture of this, it's got not a great lighting. There's a lot of shadow coming from the smartphone. But what image cleanup really does is it takes this image and really makes it looking much more elegant. It puts a white background. It really cleans it up. And then when these images show up for a buyer in the search page, in what we call as a viewing the item page, they look much neater, much cleaner, and really our buyers love them. So this is again a feature that we rolled out last year, enabled by computer vision. But today I'm going to be sharing with you how did we actually went about creating such an experience using computer vision. It's an exciting story. But before we get to that, as we embarked on that, there were really challenging scenarios. Now, there were the simple scenarios, which were like, hey, this purse or the wallet of black on a white background, right? Those are easy to, I mean, they're probably already nice, clean looking, or the red sweatshirt on a brown, you can see the contrast in this. But what got really interesting and challenging were some of these scenarios. As you can see, there is this child car seat with a lot of clutter in the background. How do you clean up that clutter? Or the basket in a dim lighting with, again, a kind of a printed background. Or this horse, which is actually on a black chair, a black horse on a black chair. How do you actually know which one is the foreground object and the primary object versus the background? And how do you actually do the cleanup in this case? And there were other interesting cases like, reflections, loops, or thin regions as in the handbag strap, or in some cases, transparency like your glasses. So image cleanup was an exciting project as we iterated through this. So the experience that we actually landed was, we started with the experience where we let the user really inform the user to say, hey, is there enough clear lighting? Can we actually do a good job of separating the foreground and background? So if the app knows that, hey, this is not enough lighting or there's too much clutter, we actually pop up to the user to say, you know what, you got to improve the brightness, or maybe reduce the clutter. So that gives the user a pretty good visual cue. And once that is there, the user can actually hone in. Now we do detect the foreground and the background, but in this case, what it really helps is to help the user hone in on the part of the image that is really the primary object. And once they do that, the computer vision algorithm kicks in and it's trying to do an auto cleanup, right? So it's trying to go in there and really try to identify the foreground and the background object. Now, in the case of simple images, like we saw of that sunglasses, it's fairly simple. The auto cleanup does really well in its first pass. But in cases where there are loops, that's when it gets really tricky. There's transparency, thin lines, as in the case of this handbag. So then what we actually do is we prompt the user to really go into a manual touch-up mode. And as you can see in this experience here, the user can zoom in, zoom out, and really, with the finger on the mobile app, really clean up and touch it. And the computer vision algorithm on the edge, on the device, is really trying to help the user clean up the image in here. So this is, again, where we're really leveraging a lot of the state-of-the-art computer vision technology to enable magical experiences, frictionless experiences on the device for the sellers. And our sellers love it. We actually rolled this out last year during eBay Open, which is our seller conference. And since then, there's been really good adoption in here. The next experience that I want to talk about is about the attributes itself. Now, we get over 50 million images at eBay. If you look at this image, which is a typical image in our fashion category, what can you tell about that? Maybe you could say that, hey, this is a sweatshirt. It has a hoodie. And if you can recognize the brand, you might actually call it out. Now, knowing this image, the sellers provide certain aspects, certain attributes when they list this sweatshirt. But there is so much more that the computer vision can actually enable. So in this case, the seller says this is a hoodie, the color is red, it has a solid pattern, it's Under Armour. But using our computer vision models, we're able to detect so much more. We're able to tell what style it is. We're able to say the primary and the secondary color, so that when a buyer is actually coming and searching for this, they can actually search by the color. We can even identify the pattern. We can actually extract the brand. We can say, hey, what kind of a season is it? Is it a short sleeve, a long sleeve? Another interesting thing is, although about explicit content, this picture is nice and clean, but we always have cases where there are content which is more explicit. So we try to identify. So there's a whole set of attributes that we can really extract from the images. And how is this used? Again, example in fashion, we could detect floral dresses, we could detect stripe, we could identify brands like Coach handbag. We could even define attributes such as occasion using computer vision. And how we end up using this is, as the images, the seller lists an image with the listing, we have a set of CV models in our AI platform that really predicts the brand, the color, pattern, style, occasion, and makes these attributes available for our various experiences on the eBay marketplace. So that whether it be a buyer searching by color or an occasion, or we want to surface specific merchandising recommendation in ads, we could actually do that. So this is how we actually scale our computer vision across of various eBay experiences for our buyers as well as our sellers. We talked a lot today about computer vision and image. Language is a big part of our marketplace. When a seller lists an item, there is the title of an item. It could say like, hey, Under Armour red sweatshirt. Or we could have a description that talks about like, hey, this is a rose antique chair with 3 legs. So there's a whole lot of title and description that goes into every listing. Our members, which are our buyers and sellers, continuously communicate with each other by what we call as member-to-member messages. We can look at product reviews. So the marketplace has a whole lot of images as well as text. And that's where natural language processing really comes to play when we want to process and understand and really make use of NLP to enable experiences. So here are a few examples. We can use NLP to really separate chunks of continuous text into words. This is an example of, we can also identify entities. For example, Apple iPhone X, right? We could really say which one is the brand, the model. We could do machine translation. It's a huge part of our cross-border. A listing that was listed in German, we're able to translate that so that an English-speaking user, when they come and search in English, they can actually see that listing that was created in Germany. And OCR, from image, the text on an image, and trying to basically extract that and then trying to understand that is something that's also, again, a very good use case. We do text summarization. We try to understand reviews and say, what is the sentiment of it, right? Hey, this is, if it's like, is it a good sentiment? Is it something that's not so good? So we tend to identify those. And we also try to understand the user's queries, the user's intent, right? When someone comes and says, hey, I want to buy red sneakers, right? So we're trying to really understand which parts of speech are this and which parts are entities, which parts are brand. And we try to understand such natural language queries so we can actually surface the right results, right, in our recall set, in our ranking. So we actually then surface the most relevant results to the users. But I want to pick on one specific example, an application of natural language processing, which is a huge enabler at eBay, which is around machine translation. We have a whole set of diverse categories, being able to identify examples across those and trying to differentiate between, hey, wait, are you talking about an apple brand or an apple fruit? Are you talking about petit bateau, which is like a brand, or are you talking about a small bird? So there's a whole set of semantic diversity that actually comes into machine translation. And we are really trying to enable this for our global marketplace buyers as well as sellers. So if we have to look at how machine translation works at scale, this is a continuous flow. We have 1.4 billion live listings. Now, how do we actually enable machine translation at scale for cross-border? So it's a sequence of steps. Let's say a user comes in and issues a query in a language, right? They pick Germany and they type in a request. Now, what we do is we translate that into English and into men's sunglasses. Now, what the translated query as part of the third step we do is we take that query and we actually do a search in our search engine of all of the inventory that is relevant to that particular market. And once we get the relevant results, we actually surface them back into the user's search ranking page. But at the same time, in near real time, we're actually translating the item title and the description on demand. And that's really powerful because being able to do that in split second with the right relevance and the accuracy is super critical for our buyers. And then the translated queries actually, the results are actually served back to the user. So again, this is one example of how we apply machine translation. We're leveraging state-of-the-art NLP technologies like BERT and deep learning technologies, neural net architectures to train our models in a corpus of listings, titles, descriptions, product reviews to do identify spam, sentiment analysis, machine translation. So this is again a key driver for our cross-border trade. So when we look at NLP or computer vision or recommendation, all of this is powered by a homegrown AI platform at eBay. Some of you may be very familiar with the machine learning and the AI lifecycle. For others, it starts off with an exploratory model training phase where you're trying to understand the data, you're trying to identify what model architectures and what to really train this model on. Want to play with data. So there's a data AI lifecycle. I actually have a blog on this one. If you're interested, you could go to the eBay AI tech blog and you can actually read a lot about this AI platform itself. And then once the model is trained, we have a way to record experiments. We have a repository where you can actually store and version models. And then we have a serving layer to serve and inference models in traditional CPU-based architectures or GPU-based architectures. And then with that comes observability, right? Being able to monitor the models, being able to understand model performance and being able to iterate through a feedback loop. So if you want to retrain or you want to refit. So the AI platform is at the heart of how we actually scale AI at eBay. It's how our researchers and data scientists and developers at eBay develop and deploy, whether it be computer vision or NLP or recommendation models. So to summarize, we have user experiences. We have user AI very close to the user experiences. And at the core of that are our AI pillars. We talked about some of the use cases in computer vision, in natural language processing. Now, the right and center of that is our data. And using that data, we enable wonderful experiences leveraging the power of our AI platform. So thank you. Excited to share with this and hope to be in touch with you.